that I had at the end for them, I totally screwed it up. From the beginning, like, and it took me forever to figure out where it was, and I'm like, "Oh, this is just a mess." And it's because I woke up at like 3:30 this morning to fall back to sleep. So unit circle is my favorite thing to teach. Unit circle trig is one of my favorite things. And so I do tend to spend some time on it because I like it. And the unit circle is basically talking about the equation of a circle. It's taken from the equation of the circle that you guys might remember is it E, not an S, equation of a circle, which is x squared plus y squared equals 1. And so we're talking about what happens going around a circle in radians at a unit of radius of 1. Does that make some sense? So all the way around, a radius is 1. And the whole concept behind being able to figure all these things out in terms of a radius of 1 is no matter how big our radius gets, beyond that, it's just a multiple, or how small it gets, right? It's just a multiple of the radius of 1. So they're all going to follow that pattern. They're all going to be proportionate to that. So if we know all of these measurements at a radius of 1, it'll help us down the road. And basically, it's like we're wrapping a number line around a circle, around the arc of a circle. Think about this in terms of circles and degrees and stuff like that. Counterclockwise is what we consider positive degrees, right? Right? That's the clockwise. Our counterclockwise is how we count bigger. Our negatives go clockwise, right? When we're talking about angles or radians, if we're going clockwise, we're dealing with negative angles. If we're going counterclockwise, we're dealing with positive angles. I know we've talked about that before, but it can never hurt to talk about it more. So we've talked a little bit about these points right here where we're showing these points. We know that this is 0, 1, right? And we know that this point would be, sorry, I'm already screwing up. This is 1, 0, right? Our x value is 1, our y value is 0. Technically, this would be negative 1, 0, right? Up here, well, we're going up 1 unit, so our y value would be 1, but we're not going anywhere off of the x. And same down here, we're going to the negative 1 unit, and our y value isn't moving anywhere. So in terms of these points, we've discussed them before, right? These aren't anything new. What else do we know about this? We know that it is 0 degrees, right? We also know it is 360 degrees. What else is it if we go all the way around the circle? So if we go all the way around the circle, we have 360 degrees. What is it in radians if I go all the way? 2 pi's. Somebody's hungry. All the way around the circle is 2 pi. What is halfway around the circle? What's over here? If all the way around the circle is 2 pi, what is halfway around the circle? 1 sad pi. So in terms of that, and I know we've talked about this before too, if halfway around the circle is a distance of pi, what is this? Halfway to pi. What would halfway to pi be? Half a pi, or pi over 2, right? So if this is 0 and this is pi over 2, this would technically be 2 pi over 2, right? So this would be 3 pi over 2, right? This right here would be 4 pi over 2, but when we divided it, it just becomes 2 pi, right? If we were counting in half pies. What if, like in this case, we split this into 4 pieces, right? If we look at each half, this is 1 piece, 2 piece, 3 piece, 4 pieces. So each one of these is technically 1/4 of pi, right? So think about this. This is whoops, ooh, thing's moving. This is 90 degrees, right? As well as pi over 2. What if I was dividing this whole thing by 4 equal parts, because that's what we're looking at, 4 equal parts, and we did 180 divided by 4, each angle would be 45 degrees. And you could tell because half of that would be 90 and then half of 90 would be 45, right? So this is 45 degrees, right? But also, if we think of it in terms of pi, each one of these is pi over 4, right? 1/4 of pi, right? This is 1/4 of pi, this is 1/4 of pi, this is 1/4 of pi, and this is 1/4 of pi. Like every piece in here is 1/4 of pi. Does that make sense? Because half of this is pi, so this would be 1/4 of pi, 2/4 of pi, 3/4 of pi, 4/4 of pi, 5/4 of pi, 6/4 of pi, 7/4 of pi, 8/4 of pi. Why do I explain it like that? Well, because it helps us to kind of see what this each one of these is, right? If this is 1/4 of pi, this angle right here, our radian, would be pi over 4, right? This would be 2 pi over 4. But if you notice, 2 pi over 4 just reduces to pi over 2. This would be 3 pi over 4. Doesn't reduce. This one right here, 4 pi over 4, but 4 pi over 4 is what? It's just pi. 4 over 4 is 1 times pi. So this 4/4 of pi, 4 pi over 4, just reduces to pi, right? Just like this one reduces to pi over 2. This would be 5 pi over 4. This one would be 6 pi over 4. And if we divided each of those pieces by 2, we'd wind up with 3 pi over 2, which is our simplified version of 6 pi over 4. Then we could go here and we'd have 7 pi over 4. And then this technically 8 pi over 4. 8 divided by 4 is 2, gives us 2 pi. Make some sense on how we find these numbers going around? So that deals with our 45-degree angles, right? If I come down here, I'm dividing the whole top half into 6 pieces, right? And if you think about that, if we were talking about this being 0, I'm going to change colors so that we can see which one was this graph and which one is the other graph. So if this is 0 and this is 180 degrees, right? And we were dividing that into 6 equal parts. Like for the top half, we could divide the bottom half into 6 equal parts too, right? Each angle would be 30 degrees. We go 180 divided by 6 is 30. And so we know this is like 30 degrees. This is 60 degrees. This is 90 degrees. And we'd know all that, right? Was this 120, 150, and then our 180 that we're left with, right? But we also know that this is 0 and pi. So if I was dividing it by 6 and I needed radians, well, this would be pi over 6, right? Each of these pieces would be an amount of pi over 6, just like above was pi over 4, because we split the above piece into 4 equal pieces. So it was pi, 1/4 of pi each. Radian was 1/4 of pi. Now we're dividing it into 6 pieces, so each piece would be 1/6 of pi. So if I was going around the circle, this right here is pi over 6. Oops, that is a 2. I said 6, I wrote 2. This right here would be 2 pi over 6. And when we reduced that fraction, it would just be pi over 3, right? This 3 pi over 6. And when we reduce that fraction, we get pi over 2. 4 pi over 6. That's going to reduce to 2 pi over 3. 5 pi over 6, not going to reduce at all. 6 pi over 6, well, that's just pi, right? 6 over 6 is 1. This gives us pi. 7 pi over 6. 8 pi over 6. Well, that one's going to reduce. We're going to get 4 pi over 3. 9 pi over 6. Again, going to reduce to 3 pi over 2. 10 pi over 6. Again, we'll reduce to 5 pi over 3. 11 pi over 6. Can't reduce because 11 can't be reduced. And then 12 pi over 6 is just 2 pi. Does that make some sense to you guys on how this is put together? So I am going to, please tell me that I have it. I don't have it in here. This is the main makeup of a unit circle. Well, how if I shrink it so you can see both of them, Kevin, or does that make it too small? So in terms of this, we use these pieces to help us solve our 6 trig identities. And I do want to talk about our 6 trig identities, but what I'd mostly want to do is I want to bring up a big unit circle so we can put all of these pieces together and talk about the values in terms of the 6 trig functions that we deal with. And you guys are really familiar with 3 of them, or at least you should be, from geometry: sine, cosine, and tangent. And we will be introducing their counterparts, which are cosecant, secant, and cotangent, which are just literally inverses of sine, cosine, and tangent, and how they relate to the unit circle. Kevin, are you good? I want to change forms, but I don't want to do it while you're, okay, thanks. Hopefully I can pull up the right form. Fingers crossed that it's going to let me convert this to a PDF while we're sitting here. But hopefully that'll happen quickly for us. Oh, good. That's the wrong form, though. That's the same one we were on. Let's try this one. So this is basically your form. This is what you're going to have to fill out on your own later. But I am going to fill it out for you here, which is why I said, remember earlier I said you could just always go to the video. If we think about this, this is our point, right? This is our 1, 0. Why is it using that? I want to use this. This is our 0, 1. This is our -1, 0. And this is our 0, -1.